Howdy everyone, this is Boone, and today I'll be going through the probably two most requested problems for this channel. US Coast Guard 1437 and US Coast Guard 1467. For these two problems, you will need Table 3 velocity at any time. These problems are covering what is the velocity at what is the time at a certain velocity of the current. If you watched the velocity video on this channel, which you can look back earlier, and you understand the concept of this, I promise you will be able to understand these principles as well. So let's get started. 1437 states, determine the time after, not the date, time after 0300 Central Standard Time, ZD plus 6. When will the velocity of the tidal current will be 0.5 knots on 16 April 83 at Port Arthur Canal Entrance TX. I abbreviated that because we are simply copying and pasting this bit into the tidal prints. Now, this is not Central Standard Time. This is not a daylight savings time problem. And we have one more bit of information we need to add to the sheet. It says on here that the tidal current will be 0.5 knot. So let's go down here to velocity at any time and put it in 0.5 knots. Now, this is all the given information we have for the entire problem. Now, let's get into the reprints. So, let's copy and paste Port Arthur Canal, Texas. Now, since Port Arthur Canal is in the correct page range for tidal currents, we know this is the correct one. So, let's copy down these numbers right here. So, reference station is Galveston Bay Entrance. And really the only important part about this one is page 124 of the currents. The minimum before flood is plus 0.53 minutes. Plus 1 hour, 34 minutes. Plus 0 hours, 55 minutes, plus 1 hour, 12 minutes. And our speed ratios are 0.5 and 0.6 for ebb. Now for the two US Coast Guard problems, you do not need the flood direction, and you can't really see that, but I just zoom that over to show that these were the numbers that I'm copying from on page 226 of the PDF. Alrighty, now that we have our reference station, let's go to that. So my suggestion is just in that bit of text right there, copying it, putting it right up here. Keep on hitting next till you get to this. And it should line up with the page you copied down, page 124. As you can see right here, you copied that down. You can see that's page 124 right here. Alrighty. So let's find April. Should be on the second page of this. And it is. April 16th is right here. We're going to copy that whole thing. And let's move this over and zoom in on here. Alrighty, now that we have that, you can kind of see this. I'll copy this again so you can see what I'm copying down. Oops. Alright, So we need to find after 0300. So the times that fall between 0300 are 0244 and 0639. Now we need to make sure after the we add in the substation that still works, but we're taking an estimated guess right now that these are the two times we're trying to find. So let's write in 0, 2, 4, 4, 0, 6, 3, 9, with a velocity of 2.2 f. And then let's add in the substation. So these are both flood, so we'll just cross out the ebb part of it so we don't confuse ourselves. And 0244 plus 53 minutes. And 0639 plus 134. Double check that we have the right numbers and we're pointing it from the right place, because it would be bad if we were pointing the ebb numbers. 53, 34. Cool. Now we need to add in 39 plus 34 is 73. Let's subtract 60 and add an hour. So that'd be 13. Then we'll add an hour in. So that'd be 7, 8. 08, 13. And 44 plus 53 is 97 minus 60 is 37 plus 1 hour is 0337. Now, for this problem, it is at 0337 is after 0300, but if we look back on the 15th, which you can scroll down and see, that there is no significant change, so we can still use 0337 because the range of slack there is, I believe, from 09 to 03, so we can still use this slack and max. And then we need to account for our flood ratio, so 2.2 times 0.5 is 1.1 F. Alrighty. Now we need to make sure one last thing on this page. Zoom this out and go to the bottom to see, and that the time meridian is 90. This 90 divided by 15 is 6, and that does line up with ZD plus 6. So we don't have to make any more corrections there. Alrighty. So we can't find the difference between slack and desired time because we are trying to find the desired time. But what we can do is find the slack and maximum current difference. So 0813 and 0337. And sorry if the camera's blurry or the fact that I'm left-handed. I'm trying my best. 07, that'd be 73. I simply took an hour from there and added 60 minutes to that. 73 minus 37 is 36. 07 minus 03 is 04. So the difference between slack and maximum current is 04 hours, 36 minutes. The maximum current is 1.1 F. So 1.1 flood. Now, here is the primary formula that separates it between a regular velocity and the velocity at the time for a certain velocity is this one simple formula. V divided by MC equals F. What is that saying? Velocity divided by the maximum current equals the factor. The factor is what you'll use to add to the slack to find the given time. So V in this case is 0.5 divided by 1.1, which would be 0.45, which in this case we are using tenths, so round up to 0.5. Alrighty, now that we have our factor, we can go on over to table 3, the title of the velocity of a current at any time. And we're going to similarly work back as we do in high type problems for at that certain time. So we have our factor and our interval between slack and max. So since we are not in Cape Cod Canal, Hell's Gate, Chesapeake Bay, Delaware Canal, and all other stations, we're going to be using table A. Let's go to table A. And let me zoom in on that just a little bit so you guys can see it better. Alrighty, so our difference between our slack and max is 4 hours and 36 minutes. We're going to go over to where that lines up closely, which would be 4 hours and 40 minutes. And then our factor is 0.5, which is found right here. So now that we have that, we're going to go over to 1 hour and 40 minutes. And just remember that number. Now, that is our difference between the interval between slack and desired time. So, since we know our slack, and we know the difference, all we have to do is add them. So 3:37 plus 01:40. So 37 plus 40 is 77, minus 60 is 17. 3 plus 1 is 05. So the answer is 0517, which is not a given answer for this problem. The only possible answer choices are 0436, 0507, 0538, and 0554. So we can deduce easily that 0507 is our correct answer for this situation, and I have found no other way after doing this problem multiple times that I can get a exact 0507. If you are able to get a 0507, please let me know, as I would be very interested in how you got there. But this method consistently works between both problems, so I will be using it. Now that we have 1437 done, let's move on to 1467, which we'll be using a similar process. But since there is only 2 of these types of problems in the whole question database, I thought I'd cover both of them in the same video. So let's go on down to 1467. 1467 says, determine the time after 0737 Eastern Standard Time. After 0730 Eastern Standard Time, ZD plus 5, when the velocity will be 2.1 knots on 26 March 83 in Fort Again, I just abbreviated that because we're going to be copy and pasting that right into the reprints. Central Standard Time is not daylight, so we're going to say no to that. And we have one more piece of information to add to it, which is the knots. So we're going down to the velocity. We're going to write in 2.1 KNOTS. Now that we have that, we're going to look up Fort Pulaski and the reprints. So let's copy that and go over here, Control F. There are 4 times that it's used. Now, 224 is in the correct current section of the book. So we can deduce that this is the correct Fort Pulaski that I was referring to. Let me zoom in on that just a little bit. There we go. Now I'm going to keep my camera here, but I'll show you the reference station is Savannah River Entrance, which I'm going to abbreviate to Savannah River Entrance on page 88. And zoom in just a little bit. Alrighty. Now we're not using 1.8 miles above or 4.8 miles above. So we're going to be using this line right here. So let's just highlight that so we don't get confused with the other ones. So, plus 0 hours, 2 minutes, plus 0 hours, 39 minutes, plus 0 hours, 30 minutes, minus 0 hours, 04 minutes. Now the flood is a speed ratio of 1.1 and the ebb is a speed ratio of 1.2. Now for these problems, like I said before, you do not need the flood or ebb direction. We're just going to scribble through that just to show that we don't need it. So our reference station is Savannah River Entrance, and what I'll be doing, like I did in the last problem, simply just copying this. And there we go. Savannah River Entrance. But the book almost got us confused, but since we wrote down the correct Savannah River Entrance, we know that this is not it. This is the tidal heights Savannah River Entrance, so we're going to go past that, go down again, and there we go. Page 88 Savannah River Entrance is on page 188 of the PDF. Now that we have that, we can go to March, which is the second page. Now we're trying to find the 26th of March, which is right here. So let me get out the marquee tool. And let's highlight these three so I can zoom in just like that. Make this a little bit bigger. Cool. I cut out the floods. Need that. Alrighty, so now that we have that, let's highlight it so we know which ones to refer to. We're trying to find after 0730 Eastern Standard Time. So we're going to make an educated guess that between these three numbers right here, 0730 will fall between it when added in the correct times. I'm going to make a further assumption that it'll be between these two, but I'm going to adjust for all of them in case 0656 falls out of line. So 0340 velocity of 1.8 flood, 0656 and 1024 2.9 ebb. Now we need to add in the corrections from above and make sure we are using the correct ones. So 0340 from the max, so that would be plus 40 plus 39 is 79 minus 60 is 19. That would be 04. And we're going to cross that out. We're not using a min before flood, so we're going to cross that out. 0656 is plus 30. So 56 plus 30 minus 60 is 26. That would be 0726. I'm going to cross that out. And 1024 minus 4, simple math, 1020. Now we got all those accounted for. Our flood is 1.8 times 1.1, which is 2.0, and 2.9 times 1.2 is 3.48, which we're going to round up to 3.5. Not 3.f. Now that we have that, we're going to be using the similar process that we did during the last problem. Now that we know that 0730 does fit between these two numbers, the top row therefore becomes irrelevant. Now we're going to do 1020 minus 0726 to find the difference between our slack and max. That'd be 09. 20 plus 60 is 80. 80 minus 26 is 54. And 09 minus 07 is 0254. The maximum current between these two times is 3.5 ebb. Now that we have that, we're going to find our factor by using our handy formula of V divided by MC equals F. The velocity is 2.1 divided by 3.5 is 0.6. So our factor is 0.6. Now that we have that, let's go to table 3. Table 3. And we are not in any of the places that call for it to be in B, so we're going to be using table A. So we know our interval between slack and max is 3 hours, because 2 hours and 54 minutes rounds closer to that than 240. And our factor is 0.6. Now we have that. Let's go down to here. Let me zoom in a little bit so you guys can see that. 0.6. 0.6 goes to 1 hour and 20 minutes. As there's between our slack and desired time. So let's take 1 hour and 20 minutes over here. And our slack is 0726 plus 0120. So we're going to simply just add these two together. We're going to get 4608. And our answer that we have found is 0846. So let me go back to the additional questions. Make this a little bit smaller. And we get that the Coast Guard answer is 0840. So this was the closest answer after multiple attempts that I could find to reach the correct answer. And is the only one out of the 4 options that is relatively close to our correct answer. So on a multiple choice test, which is what we'll be doing with, it would not be a hard choice to go with 0840. Hopefully these 2 problems have been helpful to you guys. If you have any further questions, please use the comments or text me. You all know who I am. Or just pigeon something to let me know that you're needing help, and I will be of any service. All right, you guys have a good rest of your day.